All right, good morning, everyone. Today we're going to be covering data structures. We'll be talking about stacks, queues, and not linked lists. I'll make sure that gets removed. Linked lists will be happening on Friday. So for stacks, we're going to cover the concept of LIFO, which is last in, first out. And then we have queues, which is first in, first out. And we'll be talking about what each one of these data structures actually represent. Now, when it comes to a data structure such as a stack or a queue, you'll notice that they're very similar to a list. The only difference is they have a specific functionality. When we're talking about a stack is quite literally as information gets added or pushed into our list, only the very last index of that list is what's going to be removed. So that's why it's last in, first out. So you can see in this example, we have one, it iterates all the way up to six. And then once we start removing information from our list, we're not going to remove anywhere between the stack from one all the way up to six. The only thing that's being removed is the value at the very top of the stack. This has numbers in it, which is good to reference, but remember, this is values, not just numerical numbers. And Morty, I see your message. No problem at all. Thank you for letting me know. All right, so that's the concept of LIFO. Now, the concept of FIFO is almost the opposite. It's first in, first out. So as items get added to our list, they'll continue to get added into our queue, but they're only going to be added towards the left-hand side. They're not going to be removed. Think about this kind of like a YouTube playlist, right? So if we think about YouTube here, when you add a something into the queue of your YouTube playlist, that's what's going to be next into being played. But as you continue to add videos into your queue, you're just building that playlist to have more videos inside of it. Whereas the video being played is the one closest or the oldest one that was already added into the queue. So that's the concept of LIFO and FIFO. We'll be turning this into code. Does anyone have any questions regarding both of these concepts here?
Maybe not about either one of those concepts, but just for, giggles, could you take something from the middle of a stack?
No, so we're not going to be interacting with the middle of the stack. A stack is specifically only going to be interacting with the last index. A queue will specifically only interact with the first index when it comes to removing and will only add towards the end of the queue. So that's why these specific data structures have that one functionality. They don't do other things such as interacting with the center or the beginning of the stack. At that point, what we're talking about is a list. All right. Any other questions? Okay, pretty simple functionalities that we're going to be chasing here. So here we can see that we have three specific functions that we want to be added to our data structure of a stack. We have push, pop, or peek. So I'm going to go ahead and make my class here. This is going to be my stack. I know this is going to take an init method, which for now, I'm just going to leave empty. I know that I'm going to need a push method, which is likely going to receive a value, which I will add to some sort of data structure. And then I know I need a peek method to be able to view the last value in the stack. So peek, oh, that is a mess. I apologize. Apparently I lost my keyboard skills over these last couple of weeks. Will be utilized to see the last value on this stack. All right, push will be utilized to add a value to the top of the stack. And then our init method, which should have a data structure, should initialize a data structure that is able to hold values and remove said values. All right. So let's think about this for a second. What kind of data structure would we actually utilize in this init method? And let's go ahead and call this a base, right? So we'll just go ahead and say self.base. What should be the base of my stack?
An array or a list.
A list. Awesome. Yeah. So we're going to go with the list because a list is able to hold values. We can easily add and easily pop from the end of the stack without making our life way too complicated. Awesome. So there's our base. How do we add something to the end of the base?
Dot
And,
push.
right?
Right?
Say that one more time, Chase.
Like you would use the push.
Okay. So how would that work?
Like self dot base dot push, and then you pass in val.
Perfect. And we pass in the val. Awesome. So there you go. We were able to add a value to the top of our stack. What about the peak method? I just want to view something at the very end of my stack. What would that look like?
I could be wrong, but would it be like return self dot base and then the last index?
Okay, so we could do something like return self.base and then at index -1. Okay, well, what happens if our list is empty? What would this do?
Return like an error.
Okay, awesome. So if we know that would return an error if my list was empty, what kind of condition of control can I do to make sure that I implement that this is the return statement that happens if there is values within my list, and otherwise I would return none.
Try and accept block maybe. I would, try to return that if the list does have something in it, and if not, then I would just return there like there's no items in this list.
Okay, I could definitely do something like that. Right, we could do something along these lines where we can try to return self.base at -1. If that raises an error, we'll catch the exception and then just return none. What else can we do? Is there a way that we can prevent an exception from happening?
Just check the length of the base before you try and return its negative index.
All right, so we can say if length of self.base is greater than 0,
Yeah.
so then we can return self.base at index -1, and otherwise we can return none. And so there's a couple of ways of doing this. Also remember this is truthy or falsy, so we could just say if length of base, and if that evaluates to 0, well, that would be falsy. So we could just simply pass it that way. And we could also think about the data structure itself. Is an empty list truthy or is an empty list falsy?
Truthy.
All right, let's try it out. Let's test it. Let's say bool, and then pass in an empty list and see what that returns.
It's false.
Nice. So that returns false. And if we add something that has values inside of it, that would return true.
Is it JavaScript that an empty list is true?
Yes.
Oh, okay.
All right.
In that case, could you just say if self dot base?
Exactly. We can just remove that entire if statement and just make it if there is any values inside of that base, return self.base at -1, and otherwise return none. All right. We got quite a bit of information there regarding our stack already. Let's go ahead and execute it. Let's create a stack. Let's say my stack is equal to a class of stack. And let's add a couple of values into my stack. We're going to go ahead and push 1, This is what I'm doing. All right, so that's gonna push all these values into my stack there. And let's go ahead and take a look at the base here. Does anyone have any questions regarding the syntax here on line 30 before I continue moving forward? All right, perfect. Let's go ahead and take a look here.
I guess I do. Why is like the whole line encased inside of a list?
If you don't have it inside of a list, it won't do that nested for loop. So if I take it out of a parental list, you'll see that it throws an error for that for. So it needs to be within an iterable statement. When you're doing this, it's to create a new list. Otherwise, it doesn't accept the syntax. All right. So now I'm going to go ahead and run Python main.py and take a look at my return here. Looks like I'm getting an error for push. And that is because we don't have push, we have append. All right, and there we can see that the base was successfully loaded with 1, 2, 3, 4, 5, 6. Well, let's go ahead and utilize some of the peak statement there. Let's go ahead and take this out. Let's do list of nums here. And say for num in list of nums if, and actually we'll just go ahead and load it. My stack dot push, and I want to push the number in it. If num modulo 2, so if it's an even number, then I also want to utilize my preview or my peak function, which is returning a value, so I have to place within a print statement. And at the end of it, I'll just go ahead and print my entire stack base. You can go ahead and execute this block of code. We'll see that my peak function is actually returning 2, 4, and 6, which is what I wanted it to do. And at the end of it, my entire stack has all of its information loaded. All right. We're almost done building the stack. The only thing left is the pop method. So let's go ahead and create a pop method here. And this here will be utilized to remove the last value within the stack. Or we'll just say, instead of saying last value, we'll say top. So how can I do that? How can I remove from the top of the stack?
Pop.
Yeah, it's as simple as saying self.base.pop. And the pop function actually returns something. So pop returns the value that was removed. So we could actually return that value as well. All right, so let's go ahead and do where we'll peak if it is an even number, and otherwise, we'll go ahead and remove. We'll pop from my stack.pop. And we will peek in my stack.peek. So now when we execute this block of code, we'll see that when 1 gets added to the stack, it's also popped. When 2 gets added to the stack, we see a peek. 3 gets added, but then it's popped. 4 gets added, 5, and so on. At the end of it, we have 2, 4, and 6. And that covers the concept of LIFO. Last in, first out. Does anyone have any questions over this?
I guess I do. I thought like when you pop something, it doesn't necessarily save it, it just returns it. So I'm just wondering how we got that actual list of saved pop integers
You're talking about here?
or of the peak. Oh, okay. We're just returning it at the end. Never mind. I'm checking out.
Okay,
Returning in stack base. Yeah, my bad.
awesome. No problem at all. Any other questions? Okay, awesome. Let me go ahead and move this file here from main.py. I'm just going to name this to stack.py. I'm going to go ahead and make a new file named qpy. I always have a problem spelling this. I'll go ahead and make sure I can spell it correctly. Q's. There you go. So we went over the concept of stacks, and we were able to create a stack pretty simply. Well, now let's go over creating a queue. What would that look like? Using the same information that we just learned about a stack, how could we implement a queue that covers the information of FIFO, or the concept of FIFO, which is first in, first out? What would that look like?
Like you're just trying to get like the start of whatever list you had in this example.
Sure. What would that look like?
We create the class and then create the init method. So obviously like the empty array, and then I feel like I remember in JavaScript how to get the beginning, and I don't remember in Python.
Is it like shift or unshift? Or is that JavaScript?
That's JavaScript. That's in
Is it insert and then the index number?
All right, second here, and then values. So you're saying that this one would be insert, maybe. So
Insert 0.
insert and index number. All right. Okay. And then we also need, so let's cover this one first. So I see that we have insert with an index number, but remember the concept of adding values to the queue doesn't necessarily change. Um, we could do it that way, where we're always inserting at index 0. Or we could just remove by an index. I guess it's whichever way we would like to tackle it, right? So in this case, what we're saying is we want to utilize self.base.insert. And insert takes in 2 arguments. 1, the value that will be inserted into the list. And 2, or excuse me, 1, the index where the value will be inserted. And 2, the value that will be inserted into the list. So we're saying we're going to pass in 0 and then pass in the value that gets passed. All right. Now, what would that look like when we're trying to dequeue? When we're trying to remove something from the list?
You could just remove the index.
So self.base.remove. And it seems like remove takes in a value, not an index.
Well, the value could be the and then remove index, and next within remove you do index, and then your desired index.
Oh, I see. So you're saying do self dot base
Or you could do like
and then the
length.
index would be 0.
Yeah.
Okay. So
Doesn't that take out what we just put in though if we insert everything in zero index?
No, yeah, it would be the length, not zero. Or the negative.
the way it's
No,
supposed.
no, it'd just be the length.
Nope, this is the way it's supposed to work. So
No.
as we add information, right? So I add something, I throw something into the queue. Great. So there's number one. I throw something else into the queue. Fantastic. There's number two. Well, when I go to DQ, what I want removed isn't my number two, it's my number one that I want to DQ, right? So this is the correct logic that we're making here. But this isn't returning anything. Remove doesn't return. We can see there that it returns none. It doesn't have a return value. So what else could we utilize instead of remove that will actually return a value?
Could we
Uh,
pop it? But I guess I do have a question because I don't know, it's getting a little confusing for me. Because I feel like if we put something into the first index every single time we do it, it just if we remove the first index, it's going to remove the last thing that we put in, not the first thing.
The last thing that we put in, not the first thing that we put in.
Yeah, like if you put it in at index one and then you go put in, if you put A at index one and then you put B at index one, when you remove index one, it's going to remove the B, which is the last thing we put in, right?
Got it. So we're talking about our insertion method.
Yes.
Okay. And yeah, technically you are correct, right? Maybe insert wasn't the way of doing it. So what would be the way that you would handle adding things into the queue then?
Just to append it, I guess.
Awesome. So let's go ahead and append. There you go. And then we, instead of remove, we're saying that we're going to pop. So we'll return self.base.pop, and then we'll pass in the actual index that we want to pop, which in this case, it is index 0. That returns from the beginning of the queue.
So wait, append should remove at the end, right? Or add to the end, not.
Yes, that's correct.
So we're popping zero. I'm trying to understand what's going on.
Yeah, so what we're trying to do is we're trying to reference this picture that we have here of FIFO, right? We are trying to, we have a container, and I want to add things into this list. So I go ahead and add my handy dandy circle here. Comes in. Next, I go ahead and add a square. And then I add in a triangle. Well, as things are being added into the queue, if we flip this upside down, things are still being added to the queue at the very top. But when things are being removed from the queue in the stack, where we're removing information from the top, in a queue, we remove information from the bottom. So when it comes time to DQ, the circle leaves first, and then the remaining of our shapes drop down. Then the square would be the next one to leave, and so on. Did that clarify a little bit, Morty?
To an extent, I'm just thinking if I append, I'm adding to -1, which is the end, right? If I'm popping at zero, that's the beginning. So we're popping from a different direction. Is that what's happening? Are we
Yeah,
removing from the opposite side or?
that's exactly what's happening.
Oh, okay. Okay, thanks.
Of course. All right. Awesome. So there we go. We were able to pop. We're able to queue. Let's go ahead and make our peak method now. And when I peak, what exactly do I want to see? Do I want to see the last value of the Q or do I want to see the first value of the Q?
The first.
Awesome. So here I'm going to go ahead and return, or I can do the same thing. I can say if self.base, and I want to return self.base at index 0. And otherwise, I want to return none. And there's my entire queue. So let's take a look now. Oh, there you go. Let me open this up a bit. All right, I'm gonna make my queue, which is going to be an instance of a queue. And then I'm just gonna load it up with numbers. So let's do letters this time. All right, let's go ahead and add all these queues here. Gonna go ahead and add it into my counter. Or excuse me, I'm gonna add it. I'm gonna say my queue dot nq, meaning I'm adding into the queue a letter. And then I'm gonna make a ternary statement here. I'm gonna say if counter modulo 2, then I want my queue to peak. Now this has to be
Are we going to be able to do that with letters?
yes. I'm confused by your question. Could you help me out?
As you typed a little bit more, that was kind of on me because the counter is the number that we're trying to get a modulus of, not the individual letter being the string.
Right. Awesome. All right. Else, we'll go ahead and print pop. And then we'll add to our counter. There you go. And then finally, we'll go ahead and take a look at the base here. All right. So then we can take a look at the base. We can see that every single time we're adding to our queue. Now 0 modulo 2 is 0, so we were able to remove, or excuse me, it looks like that didn't work out. So that went straight into the pop method of dequeuing. So we removed the letter A from our queue. After that, we added the letter V, and that stayed within the stack. From then, we added the letter R. So currently our stack, let me go ahead and do this here. There you go. It's a little bit better. All right, so first we have the letter A. We then pop it by utilizing the dequeue method. We then add V. That stays, so it utilizes the peak method. We add into our queue the letter R, but then we pop the letter V because V was inside of the queue first. So V is removed. R and L then get added. Again, we peak. R is still within the stack. And then we do R, L, and S. And at this point, we finally pop R, leaving only L and S within the queue. And we could also visualize L and S being the last things there. If I just execute it one more time. And there you go. And that is our queue, everyone. Does anyone have any questions regarding the queue?
I don't have any questions on how it works, but what's a practical example of doing this?
That's a great question. Unfortunately, when it comes to real software development or making websites and what we're learning here in full stack development, you're not really going to find any use for data structures that are this advanced. A lot of the tools that we utilize already have these data structures working for us. The only example that I could think about when it comes to a queue would be a YouTube playlist, right? Or some sort of playlist. As people add into their playlist, the queue is getting bigger, but we're only taking out from where they started in making their playlist. And when it comes to the stack, I would think about it. I can't really think off the top of my head from a practical example. And if I try to come up with one, I would be lying to you, Tim. So I'm
I
not
thought of like the DMV. Like you go there, you grab a ticket, you're waiting, and then they call you.
right. I'm just thinking of a technological practical example. Um, when it comes to the reason why we need to learn these is because even though there isn't necessarily a common practice or an example within our software development or full stack development where we would utilize these data structures, it is not uncommon for you to step into an interview and for somebody to ask you to build a queue or build a stack. So it's more knowledge that we need to know to get the job, not necessarily a tool that we need to know to perform the job. Does that answer your question, Tim? Of
It does, thank you.
course. Any other questions? All right. This one was short and sweet, everyone. If no one has any questions, I'm going to go ahead and stop our recording
I have
here.
a
Oh,
quick question. Is Rod coming in or no?
it looks like it's going to be happening tomorrow. I apologize, everyone. There was a problem in scheduling, so that will be happening tomorrow. All right. I'm going to go ahead and stop our recording now.